Alright, for this lesson we're going to take a look at some of the uses of prime factors and prime factorization. So like with the last lesson, we know how to express numbers as prime factors. We're going to divide by the prime numbers, starting with 2 until I can't do it anymore. And then once it's all prime numbers, I can state the multiplication of all those prime numbers. For 72, I'm going to do the same process, and I'm going to get 2 and 36, 2 and 18, 2 and 9. Can't do 2 anymore, so now I'm going to get 3 and 3. Which means that 48 is going to be equal to 2 times 2 times 2 times 2 times 3, or 2 to the power of 4 times 3. 72 is equal to 2 times 2 times 2 times 3 times 3, or 2 to the power of 3 times 3 to the power of 2. Now how can I use these different forms of the prime factorization? Well, one way is to solve for what's called the greatest common factor. If I'm trying to find the largest whole number which divides perfectly into each of the numbers in the set, then that is the greatest common factor. For example, if I have 8, 16, and 20, I know I can divide all three of these by 1, all of them by 2, but the biggest number I can divide all of them by is actually 4. Now frequently, when we're looking at smaller numbers, it's pretty easy to pick out what the biggest number I can divide them by is. If I had 15, 25, and 35, those are all divisible by 5. If I have 18 and 20, those are both divisible by 2. They're both even numbers. If I had 36 and 54, I can divide them by 1, 2, 4, 8, 9, and then the biggest one is actually 18. So, examples A and B are pretty obvious, but once you get to C, when you get bigger numbers that have multiple factors, sometimes it's hard to pick out what the biggest factor is. You can probably pick out a number you can divide them by, but not necessarily the biggest one. This is why we use the prime factorization. When we're using the prime factorization, we're looking at, from the expanded form, what exists in every number in the set. So if I had the numbers 48 and 72, and we said that for 48 it was 4 2's and a 3, for 72 it was 3 2's and 2 3's, well, they both have at least 3 2's, and they both have at least 1 3, which means that 3 2's and a 3 is the factors that is the same between both of them, which means if I take all of the factors that they have that are the same and multiply them back together, you're going to get what the greatest common factor is. In this case, it's going to be 24. So if that's true, the first thing we need to be able to do is we need to find what the prime factorization is. Once we know the prime factorization, we're going to state what the greatest common factor is. So whatever method you prefer to use, you can use a factoring tree, you can use the birthday cake method, you can do it vertically, however you like to find the prime factorization. If I'm taking the prime factorization of 90, the 90 is going to be the same as 2 times 3 times 3 times 5. 225 is going to be the same as 3 times 3 times 5 times 5. And I'm looking for what is the same. Well, they both have 2 3s, and they both have a 5, which means that I can state that the greatest common factor, or we just call it GCF for short, is equal to 3 times 3 times 5, which in this case is going to give me 45 is the biggest number I can divide both these by. If I'm taking a couple of bigger numbers, 154 and 198, the process is still the same. 154, when I factor it down, is equal to 2 times 7 times 11. 198 is going to be equal to 2 times 3 times 3 times 11. And I can see that they both have a 2, they both have an 11. The greatest common factor is equal to 2 times 11, or both these numbers are divisible by 22. Now these are all cases where I'm doing it with just 2 numbers. What if I'm doing it with 3 numbers? What if I'm doing it with 4 numbers? The process is identical. It doesn't actually change anything. So as long as I can list out what the prime factorization is, 245 is the same as 5 times 7 times 7. 315 is the same as 3 times 3 times 5 times 7. And 770 is equal to 2 times 5 times 7 times 11. And once again, we look at what's the same. All of them have a 5. All of them have a 7. Which means the greatest common factor is going to equal 5 times 7, or 35. For example B, it has 4 numbers. Process is still the same. 171 is the same as 3 times 3 times 19. 285 is the same as 3 times 5 times 19. 399 is going to be the same as 3 times 7 times 19. And 1140 is going to be the same as 2 times 2 times 3 times 5 times 19. What's the same with all of them? They all have a 3. They all have a 19. Three times 19 means that they're all divisible by 57. So all it is for greatest common factor is write the prime factorization in the expanded form and just circle or look for what is the same with every single number. It has to exist in all the numbers in the sets, otherwise it is not a common factor.